Okay, the product validations have quite a bit going on. Um, the maximum pressures, dimensions, this follows from the test report. The test report being used as the basis of the system's configuration. Um, we can also, create hyperlinks to this information. So if we go ahead and go to edit, we have the name, approval authority. If we're just making something up for our own convenience of estimating, I like to use user, but otherwise, most of the storefront products that have been configured rely on the product approvals from either of those entities. This would be the link to that document on the state's website. So that's this URL. These can have expiration dates. Approval restriction refers to the Florida Building Code. We have a special high velocity hurricane zone, which is Miami-Dade County, Broward County. Not all systems in Florida are approved for use in those areas, or at least it was so formerly. We also have a document reference number. That is intended to be the state's product approval ID number. The maximum pressures tested, if we comb through this report, we see 80 pounds, 94 pounds. We don't see pressures in excess of 94 pounds. The maximum tested height of the mullion components is 12 feet. And the maximum width in the test report, there is no maximum width. Theoretically, a storefront can have an infinite width. So we're just using basically 1,000 feet. It's a large number. And finally, the validation can have one type of door frame. If the product system is registered to a particular vendor, then the validations will only be able to use door frames from that same vendor. So all of these door frames are configured for TrueLight, and they're available to be associated with this validation report. So that's the basic gist of information associated with the product validation. Now, more importantly, let's talk about the components. Okay, the components are drawn in the elevation, and as we hover the mouse over them, they highlight in the pink color. Components follow loosely from the geometry that we define in terms of columns and rows. So in this instance, we have one glass component. If we introduce an additional column, now we have two glass components. Okay, we also have, for each column, we have one head component, one sill component. When we have an elevation, let's say a single elevation is always going to have two jamb components, one head, one sill, one glass light. It also has an elevation component. Regardless of the number of columns or rows, elevation components are one-to-one with the quantity. So this would result in 3 elevation components being required. Each of those elevations would also have one glass light, so now there becomes a total material requirement for 3 pieces of glass. The column / section component, it's not drawn in the elevation, but it corresponds to the number of columns represented. So here we have 2 columns, we have a quantity of 3, there would be then 6 total vertical sections required. If we increase the number of rows, it increases the number of intermediate horizontal components. fairly straightforward, right? The overall sizes of the elevation dictate the sizes of these components. Okay, so this intermediate horizontal is 72 inches wide. This vertical mullion is 99 and a quarter inches tall. The actual heights and sizes and quantities of the components follow from the number of columns and rows, the actual size of the elevation, and the actual system configuration dimensions, the dimensions that are saved on the product system. Now, if you understand what I tried to explain, good luck. We have, within the context of the product validation, the ability to define these component types. Okay, so we have a glass light type. There are 3 options. We have one type of head component, one intermediate horizontal. We have a variety of different jam components. And if we look at the elevation, well, let's start with the jam. We have a variety. It's the same. The same components that have been defined as jams for this product validation are available to be selected in the elevation drawing. So if we wanted jam J2, let's look for jam J2 with reinforcement. Okay, it's going to include this particular component. This component includes this set of parts. Now, we're looking at jam J2R here. We can see the set of parts and how those parts are to be used. So 3301 head sill jam, that's the metal frame component that is reinforced by the steel. 3301 is assigned the vertical component height. If we look at the elevation again, the length of this component is 99 and a quarter. You can go ahead and save that. It's 99 and a quarter because our opening height is 100. We have no receptor deductions, and our shim spaces combined top and bottom, it's 3/4. So the different parts that are associated with components, that the association is made with what you can think of as a formula, a relationship to the elevation's size and its configured geometry. We have elevations, glass lights, head, horizontal, jam, mullion, sill, and the vertical section component types. We can create these components by giving them a name. Ordinarily, I would consider it a best practice to use the same name that's represented on the document that you're using as the basis of configuring the system. It's also worth mentioning that the component names, the images, the parts, all of this stuff is used to create the proposals that go to our customers. So you don't want to undersell it and or use a confusing or shorthand type of way of describing what your intention is, because then your proposal might not clearly represent what's being provided. So the fundamental component types available for this type of storefront system where the verticals run through, it includes these component types. We did not talk about the angular, head, sill, mullion, jam, or horizontal. The angular component types are not yet supported in the drawing. But we'll create an example mullion just for fun here. Now, our face dimension is going to be the observable dimension in the elevation. It's this, the width of, we have the moment of inertia. That's useful in determining the deflection as well as the section modulus. We also have the ability to record a U value. Presently, we don't calculate the U factor of the elevations after they're drawn, but in the future we expect to be doing that. So if you have the information handy, you might consider including it. And then finally, do we want this component to be drawn into the elevation by default when it's very first loaded? When you first open this page, we're going to say not default, and we're going to create that. When we first draw the elevation, or better yet, we'll go ahead and we'll add a new elevation. Okay, by default, it has these different components. These components, jam J1, that's the default component. Nothing has been selected or changed yet. But we can come in here, change it to whatever jam we want to, and save it. This jam is not changed yet. It's the default one. Okay. So if we wanted to include an additional column, okay, and then we just created an additional type of mullion, okay, a face dimension of 9. It just shows a much larger dimension right on the face. So you might be able to represent corner posts, angular mullions by using a slightly larger face dimension. But if we look more closely at the mullion that we just created, there are no parts. So we can add parts, and that's going to be a separate video for that. We could add the section drawings, which is going to be an image file, like a JPG. And we can add the constraints. Those constraints, if we take a quick look at the jam, we can see that it has, constraints that follow from the product approval. And I have not a real good handle on where this is, so I'll just pause the video. Okay, so for jam J1, we have an exterior interior pressure for each frame height, for each frame width. Frame width is given by the daylight, well, really center to center line dimension of the mullion. In our case, we're looking at the jam to the mullion because we're concerned with jam 1. If we scroll down, we can see it was tested at 144 inches tall with a center line to center line dimension of 42 inches, and it passed at 64 pounds per square foot. Within Bid Unity, our jam's effective spacing is only half of the daylight. So that jam is carrying basically half of this daylight width. Reporting the daylight width is 42, and we want to encode that for the jams at half of the value. When we look at the mullions, let's see what we have for mullion 1. Mullion 1, similar table, same basic information, but you're not going to reduce that. You're going to go with the same center line to center line of the jam. These are the moment of inertia section modulus that I mentioned a few minutes ago. They can be associated with the mullion component. Here they are. And when we include this information, we're able to apply constraints. So if we wanted to apply the Florida product approval constraints, that's just simply going to look at what was the tallest tested size. So this was tested at 144 inches, but only a 36-inch wide effective spacing. Our effective spacing in this case is 48 3/4. We look at 47 plus 1 3/4, center line to center line dimension. We've got a little more than mullion number 1 can handle. Perhaps we'll try mullion number 2. Works out. Okay. But most of the country isn't all that concerned with Florida product approval constraints. Instead, they want to know about the actual deflection of the mullion. So if we have included the section and moment of inertia, the section modulus and moment of inertia, then bid unity will calculate the deflection. Allowable deflection is taken as 1/175th of the component height, and we can use this to qualify which component is appropriate to use in the bidding process. So for example, if we have an elevation of this nature, we can see this fails. Okay, so we better pick something else, maybe that has some steel in it, some steel reinforcement. There we go. And now I'll include the value of the steel in my proposal. So I can go ahead and save that. Because I selected mullion 2, my parts list is going to be determined according to those parts which are associated with mullion number 2. And that includes ST330. And if we find mullion 2, we have somewhere in here ST330. That's the vertical component height. Adding to that negative 48 inches. So I think that was a result of 81 1/4 inches for the steel. We'll get into the configuration of the parts, the formulas, and associations with labor when we talk about the parts. But if you were able to follow through with the idea of the geometry and how we can associate different components with the elevation drawing, you're well on your way to making the most of the software and organizing systems in a way that you can price them efficiently and very accurately.